Actually, what is our pitch? That is SmartPredict Intelligent Motor Fault Prediction. We are going to just pitch this in the round two of one of the hackathon. We are actually the member of two. My name is Aish Kushwaha and my friend is Karan. Say hi, Karan, to the public.
Hi everyone.
So, what is the pitch? It is a smart predict intelligent motor for prediction. And see how it is fascinating that you are getting to know the future before it is going to happen. In our case, this is the motor for prediction. Without getting the time to be very, very waste, let's see what it is. It is an AI predictive maintenance for the rotating machine. I hope what is the meaning of rotating machine is aware to you people. If not, our friend Karan will tell you.
Okay guys, rotating machine. So if you am saying that rotating machine is included in your day-to-day life, okay. So any product you are using that made by using the rotating machine, like any industry making any product, so that there is use an production line, assembly line. So for that we use the rotating machines. It could be AC machine or a DC machine. So everything is gathered by the rotating machine. Yeah, I
Thank you
should
so
continue.
Thank you so much, Karan. Let's move to the next slide. What it is saying, we are very, very curious to see that. The team structure. What is the team name of our? It is electrical squad. And this is our logo. I don't know you people can see or not. I just gave a very large amount of the time of mine. Okay, so let's move to the most important part. What is the problem statement? It is the unexpected motor failures. Actually, which is the motor which is very, very widely used in the industries? Induction motor or synchronous motor? My friend Karan will tell you.
Okay, so unexpected motor failure. If I'm saying, okay, so our problem statement is a motor failure. You know, in any industry, the biggest problem is motor failure, which is unexpected, and it takes a reactive maintenance. Reactive maintenance means after the failure, the company goes to resolve the problem, which is leads to time, and there is begins of the loss of the company, cause the whole production line gets hold on it. And after that, the solving the problem of motor still hold on, cause we don't know the problem. We have to know the problem after it. So this is our main statement, that we will know the problem before it will get into the uh, maintenance, reactive maintenance. So further will explain by Ayush.
It's a very, very great explanation which is given by the Karan. Actually, he said what are the traditional approaches as well as what are the futuristic approaches. Traditional approaches involving the reactive maintenance and the prevention of your opportunity is the using the ML algorithm. So let's move to the next one. What it is? Our solution. What may be the solution? As I am telling to you people from the very, very initial point, it is our smart predict. With the help of the smart predict, what we are getting the continuous monitoring. After each 15 seconds, after our sensor, that is accelerometer, is going to just sense the vibrational data of the induction motor. Induction motor is very, very large as compared to that of the synchronous motor in quantity in the power plants. What is the main reason behind that? Because the induction motor are very, very robust in nature, whereas synchronous motor is running at a very, very constant speed, and we need the different types of the speed means the varying in the speed we want. That's why we are using the induction motor. So let's go to the next thing. This is our solution, continuous monitoring with the help of the ML based system that is going to monitor the motor vibration data. Why it is said as intelligent? Because it is going to just do the things without the intervention of the human.
Ayush, Ayush, would you
Yeah,
please explain the machine learning based system? As you said that we will monitoring. So what do you think? Which types of problems the machine learning model can solve? As per our smart predict intelligent motor, we build it. So could you explain about it?
yeah, that's a very great question which is asked by the Karan. That is, what are the process which is employed in the scalable implementation? That is the sensor capture, data processing, feature extraction, ML prediction. For this, we have to just transfer our presentation to the code structure. So let's visit this link. It is actually a link.
That's
It,
great, Moa. Creative presentation.
yeah, thank you, thank you. So that is the lab I used in order to do the machine learning. So what we did something like installing the libraries like LAML. And what is this LAML? LAML is a lightweight auto ML. See, I can stretch its output. See, you can see that I have installed the LAML. And what are the libraries I have imported? NumPy is the library which I imported, and you can see I did the next process, that is load and visualization of the data, and after that I did the preparation of the data for the machine learning. And how this process is work. This is the extract feature method, that is RMS and kurtosis. We are taking only these two methods, that is RMS and kurtosis. Why? Because this analysis which we are taking is based on the very simple data set. What is what is this data set? It is a data set very simpler, which is very organized already. We don't have to just stress a very large amount of that. I am doing this because we have no sensor. We have no sensor, right? Current
Okay. Yeah.
we have no sensor. Why? Because it is very costly, and we both are very poor. Yeah. So the first reason was we don't have the sensor, and the second reason was we don't have the induction motor. We have the induction
Okay.
motor, but in our cooler, and we are not going to extract that. So let's move to the next point. In this point, we can see we have used the plot function, which is extracted from the matplotlib library. After that, I have called the function. I have defined the user-defined function, that is a calculate features. And if I go to the output point, we can see the normal signal shape. It is a shape of the normal signal. What is the meaning of shape? Shape means what is the x-axis and y-axis values. 243938 means it has 2,43,24,39,038 rows are there, and the columns are only one. And these are the sample, and this is about the quality signal shape. Let's move to the later point. It is a normal motor vibration. You can see it is the normal. Why? Its peak is not as very large as compared to that of the faulty motor vibration. As you can see, the red one, which is the faulty motor vibration, it is having the spikes at each interval, which is going to heat our induction motor. So what are the normal RMS value? RMS value
Okay.
is this, and 40 RMS value is 0.2. You can see the difference in between the normal RMS and 40 RMS. There is a large
Okay.
difference. And after that, we can move, that is a train and evaluate the model with planner. So what is this? We are using here SkyPy. SkyPy is the scientific Python library. And after that,
Okay.
NumPy. After that, Flamel we are going to import. What is Flamel? It is the way through which we can just introduce the auto ML in our project, which is very going to make our work to be very simpler. As you can
Okay.
see that, see, I have used, or I have fitted AutoML here. You can see X train and Y train. Here I am fitted with the help of the AutoML dot fit function. And what are
Okay.
the time budget 30 means our model will run for 30 seconds, and task is classification. Classification why? Because classification means two division. First is normal condition and the other one is
Okay.
faulty condition.
Hold it.
Yeah. So if we go to the output part, see, you can see actually what are the things which is being done by the auto. Two things. First thing, model selection. Second thing is hyper tuning. You can see here that there are many models has been used. XGBoost, Learner Extra 3, Learner R, Learner SGD. So these are the models which is being tested by our auto. But in last, after doing a lot of work, see in the last we can see after doing all these use step, actually we have imported the samples for data set. You can see here IR007, it is the faulty data set. IR07, it is also the parity, and these two are the normal data set. And after importing them, we have to just run our whole code from start. So run all. See, you can see that our code is running.
Waiting flavor.
This is the second
Library
step.
books, data for machine learning,
Yeah,
and
this step is also completed. Now it comes to our wait for the last step, that is a model prediction. See, you got something. What is this? Is there any error or something else? As a ML enthusiast as well as an electrical engineer, we have to build some patience in each part of our life.
Lots of patience, bro. We have 4 years.
Yeah, you have 4 years, I have 3 years.
3 years. You will be going through afterwards 4 years. Not to
Yes.
worry about.
So we can see here, our best model selected by Flamel is LGBM. LGBM is one of the model which is best for classification plus purpose. And here we can see the accuracy is 1. What does it mean? It means 100% accuracy. It means our model is working 100% accurate. But in real life, it is not possible. Because it is possible here because our dataset was very, very clean. And from where I imported the dataset, do you want to see that? See, I
Okay.
have imported the dataset from this Case Western Reserve University. I downloaded the dataset from normal from here and here from the bearing fault dataset. So
Okay.
that's how. Let's come to our project.
That's it. Last.
Okay, so let's go to our main project where Karan will explain us something very, very precious which will change your life. So it is a technical approach. What is the technical approach? I had told you about CWIU bearing dataset from where I fetch out the data. So leave this step. Pre-processing is also done by cleaning the dataset as our dataset was already clean. And feature extraction, RMS and kurtosis. I explained you earlier in the code in itself. Model selection done by the planner. And what is our result? Our result is something like visualization of the normal versus faulty motor signature. I told you people about these two plots, how our model detects them in a very, very easy manner. Now it comes for the impact and benefits. Our friend Karan will tell you about this.
बेसिकली होता क्या है कि रियल लाइफ में जो होता है कि कोई भी कंपनी है या फिर इंडस्ट्री है तो उसका सबसे बड़ा प्रॉफिट कहाँ से बनता है? जो होता है वो जो उसकी प्रोडक्शन लाइन, असेंबली लाइन या फिर क्वालिटी लाइंस हो गई। तो ये सब अगर स्मूथली चलती है तो वो जो कंपनी का जो कॉस्ट है वो बढ़ते जाता है, यानी कि मार्जिन बढ़ते जाता है। तो अगर इस सिस्टम से हम क्या करेंगे कि कई बार जैसे कि मोटर फॉल्टी कंडीशन में आ जाती है तो डाउन टाइम आ जाता है, तो ऐसे में क्या होता है कि पूरी लाइन जो है वो रुक जाती है। ऐसे टाइम में प्रोडक्शन लाइन हो गई, असेंबली लाइन हो गई, ये सारी लाइन्स रुक जाती है। तो इससे जो होता है सारे वर्कर्स एक ठप पड़ जाते हैं कि पूरी लाइन रुक गई, किसी को कोई काम नहीं है, मोटर ही फॉल्टी है। न अगर हम अलग-अलग मोटर्स यूज़ करते हैं, जैसे कि हम असेंबली लाइन्स में जो होता है हम डीसी मोटर्स यूज़ करते हैं और जो डीसी मोटर्स होती है बेसिकली अगर उनका फॉल्टी डिटेक्शन ना किया गया ना तो उनको रिज़ॉल्व करना बहुत हार्ड हो जाता है। तो ये एक अच्छा फैक्टर है कि अगर फॉल्टी कंडीशंस को हम प्रिडिक्ट कर ले, पहले ही प्रिडिक्ट कर ले हमारे इस एमएल सिस्टम से, तो ये रिड्यूस टाइम कम हो जाएगा। और अगर रिड्यूस टाइम कम होता है तो यहाँ पे हमारा दूसरा फैक्टर आ जाता है, जो कि होता है कॉस्ट सेविंग। अब सिंपल सी बात है कि अगर लाइन स्मूथली चलेगी, प्रोडक्शन अच्छे से होगा, तो हमारा जो है कॉस्ट सेविंग हो जाएगा, वर्कर्स अच्छे से काम करेंगे। दूसरा है एज डिप्लॉयमेंट। एज डिप्लॉयमेंट की अगर मैं बात करूँ, तो अगर हमने ये जो हमारा मॉडल है, पहले प्रिडिक्ट करना कि मोटर जो है वो फॉल्टी कंडीशन में आ चुकी है, वो अगर हम अलग-अलग जो है, जो इक्विपमेंट्स हम कंपोनेंट्स यूज़ कर रहे हैं कंपनी में, उनमें भी यूज़ करें, तो शायद ये जो लेटेंसी है वो बढ़ जाए और हमारा कंपनी का जो रिड्यूस जो डाउन टाइम है वो हम कर सके। नेक्स्ट स्लाइड पे जाते हैं कि फ्यूचर स्कोप्स क्या हो सकते हैं इसमें। तो इसमें फ्यूचर स्कोप्स पे हम जाएँगे, 1 मिनट वुड यू प्लीज़ हाँ, ओके। सो हियर इज़ अ फ्यूचर स्कोप एंड डेवलपमेंट। तो इसमें आता है पहला एक्सपांड फॉल्ट डिटेक्शन। अभी हम जो है इनर रेस फॉल्ट डिटेक्ट कर रहे हैं, जो हमारा जो सिस्टम है वो इनर फॉल्ट डिटेक्ट के लिए। आगे चल के हम इसके आउटर रेस सरफेस के फॉल्ट्स भी ढूंढेंगे। अभी क्या करें हम बॉल बेयरिंग फॉल्ट्स और बहुत सारी चीजें ढूंढ रहे हैं। आगे जाके हम दूसरे मैकेनिकल समस्या डिटेक्ट करेंगे जो मशीन लर्निंग मॉडल यूज करके। दूसरा होता है रियल वर्ल्ड टेस्टिंग। हमारा जो ये मशीन लर्निंग मॉडल है इसके लिए हमने स्मॉल डेटा यूज किया है। हमने वाइडली नहीं गए, जैसे कोई हमने सेंसर्स नहीं यूज किए गए अच्छे से, और एज वेल एज हमने सिर्फ वाइब्रेशन डेटा लिया है जिसके आरएमएस वैल्यू और हम जो है क्यूरेटस, वो दो चीजें हम यूज कर रहे हैं और उसके बेस पे जो है हम ये बना रहे हैं कि हमारी जो मोटर है फॉल्टी कंडीशन में है या नहीं। यहाँ पे आप और चीजें भी देख सकते हो, जैसे करंट हो गया कि करंट अगर ज्यादा मोटर ले रही है तो वो भी एक पॉइंट हो जाता है कि आप वो भी देख सकते हो कि उससे भी मोटर फॉल्टी कंडीशन में है या नहीं, या फिर मोटर से ज्यादा आवाज आ रही है, वोल्टेज ओवर वोल्टेज हो रहा है, वो सब चीजें ये हम आगे जाके रियल वर्ल्ड में टेस्टिंग करेंगे। और रियल वर्ल्ड यही प्रॉब्लम्स है बेसिकली। और टेम्परेचर भी एक टाइप की प्रॉब्लम है कि मोटर ओवर हीट हो रही है, तो उसको भी हम जो हमारा मॉडल है मशीन लर्निंग मॉडल, उसको वो डेटा प्रोवाइड करके वो हम उसको और ट्रेन करके आगे के फ्यूचर स्कोप्स के हिसाब से देख सकते हैं। अगला है लाइव डैशबोर्ड, मतलब लाइव मॉनिटरिंग डैशबोर्ड हम बना सकते हैं। हम क्या करेंगे कि एक वेब बेस्ड डैशबोर्ड डेवलप करेंगे, जो कि हमने मशीन लर्निंग मॉडल यूज करके जो भी डेटा कलेक्ट किया है और जो फॉल्टी कंडीशन हमारी होगी उसको हम जो है हमारा वेब बेस्ड डैशबोर्ड है उस पर डिस्प्ले करेंगे। ये ऐसा होगा कि आप कोई व्हीकल चला रहे हो, जैसे कि हम इलेक्ट्रिकल इंजीनियर्स है, तो हम इलेक्ट्रिकल व्हीकल का एग्जांपल ले सकते हैं कि बैटरी जो है वो उसकी रेंज है कि कोई 300-400 किलोमीटर, बेसिकली इतना होता नहीं है लेकिन हम सपोज करते हैं। तो वो 300-400 किलोमीटर पे जा रही है और उसकी बैटरी डाउन हो गई, तो वहां पे डैशबोर्ड पे अलर्ट आ जाता है। बेसिकली ईवी में ऐसा सिस्टम है कि जो बैटरी है वो 25% तक आ गई तो ऑलरेडी डैशबोर्ड पे आ जाता है कि okay, the next segment is the mobile integration. Basically, if we thinking about only the web-based dashboard, it will not efficient because the engineers had to be the that मॉडल ऑन देयर हैंड्स ऑन ना, जो भी चीजें है वो हैंड्स ऑन होनी चाहिए। तो हम उसके लिए जो है वो इंस्टेंट मोबाइल नोटिफिकेशन जनरेट कर सकते हैं, अलर्ट जनरेट कर सकते हैं कि रियल टाइम डेटा को कॉन्फ़िगरेट करेंगे और उसको जो है हम मशीन लर्निंग मॉडल की मदद से हम रियल वर्ल्ड वेब वेब जो हमारा बेस्ड डैशबोर्ड है उस पे डिस्प्ले करेंगे और उसमें भी कुछ ऐसा सिस्टम बनाएंगे कि जो है वो क्रिटिकल सिचुएशंस में भी तुरंत रिस्पॉन्स कर दे, तुरंत अलर्ट जो है वो हमारे इंजीनियर्स को भेज दे। हमारे कुछ फ्यूचर स्कोप है, होप आपको अच्छा लगा होगा और आगे का तो आयुष ही कंटिन्यू करेगा एंड इट वाज ऑनर टू बी गिव अ चांस एंड अपॉर्चुनिटी टू स्पीक मी। थैंक यू सो मच।
Very clear and great explanation given by the Karan. Actually, I am very impressed because he uses the things which is out of the box. He said something like from his own experience. He might have some develop some mobile application in his childhood times. Actually, he has given something like how we can implement the real time mobile integration with this our smart predict. Thank you so much, Karan. I am sure that it is going to hit the public mindset as well as some entrepreneur to work on this. So that's all about presentation about the smart predict. And thank you all of you for joining us. And that's all about the hackathon, we had completed. Thank you so much, Karan, to join and giving your
Yeah, yeah,
time to the public.
yeah, definitely. Goodbye, everyone. Thank you so much.